Duck typing trouble. Duck typing test for I am like a list. Usage context added at end. I often want to operate on an abstract object like a list. For example, now this appropriate if thing is a list, but will fail if thing is a dict for example. What is the Pythonic why to asked, do you behave like a list? Note: this will work for all cases I can think of, but I don't like defining a duck type negatively, as I expect there could be cases that it does not catch. Really what I want is to ask, hey, do you operate on integer indices in the way I expect a list to do? For example. Note: I do not want to simply execute my operations inside of a large try/except, since they are destructive. It is not cool to try and fail here. Usage context. A point list is a list-like thing that contains dict-like things as its elements. A matrix is a list-like thing that contains list-like things. I have a library of functions that operate on point lists and also in an analogous way on matrix-like things. For example, from the user's point of view, destructive operations like the spreadsheet-like operations column slice can operate on both matrix objects and also on point list objects in an analogous way. The resulting thing is like the original one, but only has the specified columns. Since this particular operation is destructive, it would not be cool to proceed as if an object were a matrix, only to find out part way through the operation, it was really a point list or none of the above. I want my is_matrix and is_point_list tests to be performant, since they sometimes occur inside inner loops. So I would be satisfied with a test which only investigated element 0, for example. I would prefer tests that do not involve construction of temporary objects, just to determine an object's type, but maybe that is not the Python way. In general, I find the whole duck typing thing to be kinda messy, and fraught with bugs and slowness, but maybe I don't yet think like a true Pythonista. Happy to drink more Kool-Aid.
One thing you can do, that should work quickly on a normal list and fail on a normal dict, is taking a zero-length slice from the front. The slice fails on dicts because slices are not hashable.
However, str and Unicode also pass this test, and you mentioned that you are doing destructive edits. That means you probably also want to check for _delitem_ and _setitem_. I suggest you organize the requirements you have for your input, and the range of possible inputs you want your function to handle, more explicitly than you have so far in your question. If you really just wanted to handle lists and dicts, you'd be using this instance, right? Maybe what your method does could only ever delete items, or only ever replace items, so you don't need to check for the other capability.
Document these requirements for future reference.
Perhaps there is no ideal Pythonic answer here, so I am proposing a hack solution, but don't know enough about the class structure of Python to know if I am getting this right. My reduced goals here are to simply have performant tests that will 1. Never call a dict thing, nor a string-like thing a list item. 2. Returns the right answer for Python types. 3. Will return the right answer if someone implement a full set of core method for a list/dict. 4. Is fast, ideally does not allocate objects during the test. Edit, incorporated ideas from @donged.
When dealing with built-in types, you can use the abstract base classes. In your case, you may want to test against collections.sequence or collections.mutableSequence. This is supported in all Python versions after and including 2.6. If you are using your own classes to build your underscore thing, I'd recommend that you inherit from these abstract base classes as well, directly or indirectly. This way, you can ensure that the sequence interface is implemented correctly and avoid all the typing mess. And for third-party libraries, there's no simple way to check for a sequence interface if the third-party classes didn't inherit from the built-in types or abstract classes. In this case, you'll have to check for every interface that you're going to use, and only those you use. For example, your list_ish function used _len_ and _getItem_, so only check whether these two methods exist. A wrong behavior of _getItem_, for example a dict, should raise an exception.
Wie wir, das wäre nur das Klassiker,